In this problem, you've got a circle that's inscribed in a square. The circumference is increasing at a rate of 6 inches per second. So they are giving us the rate at which the circumference is changing with respect to time. So this is 6 inches per second. And they tell us as the circle expands, the square is also going to get bigger so that this tangency is maintained. So the circle will touch the square at these 4 points every single time. And they give us a couple formulas, the circumference and the area of the circle. Okay, part A says find the rate at which the perimeter is changing, is increasing. So dp dt is what we are looking for. Okay, so we need an equation that relates the perimeter with the circumference, because we're looking for perimeter and the only thing we're given is circumference. Well, we know that the circumference of the circle is 2 pi r. And let's come up with an equation for the perimeter. So one thing I know is that the radius of this circle is r. So if I go all the way across, the diameter is really 2r. But notice that also represents one of the sides of the square. So since this is a square, that means that the perimeter of the square is actually 2r, right? 4 times around. But since I know the circumference is 2 pi r, I can solve this for r, and I can write a perimeter equation in terms of the circumference. And the reason why I did this is because I'm only given dc dt, and I'm trying to find dp dt, so I want an equation that relates perimeter with circumference. I'm going to clean this up. So now I can take the derivative with respect to time. So dp dt, the 4 over, not 2 pi, is just 4 over pi. 4 over pi is just a number, so I can pull that out. And c is your variable, so the derivative of that with respect to time is dc dt. And then I can go ahead and plug in my dc dt, which was given, which is 6. So dp dt is 24 over pi. This is the change in perimeter, so units are inches per second. Okay, part P says, at the instance when the area of the circle is 25. So at one moment in time, the area of the circle is exactly 25 pi units. That means that really the radius of the circle is 5, right? Find the rate of increase in the area between the circle and the square. So really what I'm looking for is the area between the circle and the square. So this shaded region that I'm shading right now is the area that I'm looking for. Let's come up with an equation for that area. So that shaded area would really be the area of the square. That would give you the area of the entire square. And if we subtract the area of the circle, that would give me the remaining shaded that I'm looking for. So the area of the square in terms of r would be 4r squared. The area of the circle is just pi r squared. And now I can go ahead and take this derivative with respect to t, because this is what I'm looking for. And r, we have information about. So dA dt equals 8r dr dt minus 2 pi r dr dt. Okay, notice I have r, which is going to be 5. I do need dr dt, but we know that the circumference of the circle is 2 pi r. I can find dr dt. If I take this derivative, they told us that dc dt was 6. So I can figure out what dr dt is at that one moment in time. So if you solve this, we end up with dr dt is actually 3 over pi is the dr dt. And that's what I'm going to go ahead and plug in here. So r is 5, dr dt is 3 over pi. R is 5, dr dt is 3 over pi. So your answer looks like this, and if you want to clean it up, you can. You do not need to, but another version of this answer would look like this. I cleaned it up a little bit. 120 over pi minus 30. Just units on the whole thing would be inches squared per second, though, because you're talking about the change in area with respect to time.